This is the projectile motion experiment. In this experiment, you'll be using the time of flight for projectiles shot at different angles to find g, the local acceleration due to gravity. So I'm going to outline the equipment used in this lab. First, we have the receiver pad, which consists of a piezoelectric crystal. When this crystal is impacted, it will send a signal to the timer box, and you can use that to measure time of travel of the projectile. Next, we have the launcher. This fires the projectile at 3 different repeatable speeds depending on the number of clicks that you press the projectile in when you load the launcher. Next, we have the timer box. In this experiment, you'll always be using it on 2-gate mode, which means that the starting time signal needs to come from port 1, and the stop time signal needs to come from port 2. To start the experiment, you'll be using the 2 photo gates that are attached to the launcher. Make sure the one closest to the launcher is in port 1. To set up the timer box, first press the Select Measurement button in order to set it to time. Then you'll need to press the Select Mode button 3 times in order to put it on 2 gates mode. Each time you take a measurement, you'll need to press the Start-Stop button in order to arm it for measuring a time. Throughout this experiment, you'll need to load the launcher in order to fire it. First, place the steel ball in the mouth of the launcher, and then use a pen to plunge it to the required number of clicks. For the first part of the experiment, where you measure muzzle velocity, you'll need to do several different measurements at each click setting. Here's an example of a typical measurement process. After you've armed the timer box by pressing Start, pull the string on the lever to fire the launcher. You'll see the time appear on the timer box. Once you've used that time to calculate the velocity, you'll need to switch out the second photo gate for the receiver pad. Make sure to use port 2. Next, place the receiver pad where the ball will land and measure the time of travel. In part B of the experiment, we'll be measuring the horizontal range of the ball and comparing it to the theoretical value as calculated from the muzzle velocity and the initial height. Next, remove the receiver pad and place a piece of white paper where it used to be. Tape that to the floor, and you'll also wish to tape a piece of black carbon paper to it with the black side facing down. When you launch the ball, it will hit the carbon paper and make a mark on the white paper. You will wish to measure the horizontal distance to this mark. In part C of this experiment, we'll be firing the ball at an angle, measuring the angle that produces the maximum horizontal range, and calculating the local acceleration due to gravity, little g. You may wish to temporarily unplug the photo gate from the timer box in order to adjust the launcher so that it's pointing at an angle. You'll need to unscrew the screw that holds the launcher to its mount, as well as unscrew the clamp that holds the mount to the table in order to do this. Once you've adjusted it to its proper position, tighten them again. As before, use the carbon paper to measure the horizontal range, and use the receiver pad to measure the time of flight, ensuring that the photo gate has been plugged in again. Don't forget, each time you take a run, you'll need to press Start to arm the timer box.
We hope you enjoyed this video. I'll leave you with a tip. When writing your lab report, try writing at different angles to see which one maximizes your grade.